Let's see if I can bring even a bit higher the energy level. So B.Yond, we are a Silicon Valley-based company, another one, although I'm based in Germany, in Düsseldorf. I've been here for a few years, moved from a telco business to the startup. So this is my second startup. And I've managed to actually be based in Düsseldorf, so which is exciting to make the bridge between the Valley and Europe. As B.Yond, we are the 5th iteration of the founding members. They have set up a few more companies in the US, and they've been working with the telco industry. So there's a lot of experience of providing services, mainly professional services and managed services, and that's when we realized that there's a lot that can be done through automation. And we learned from those activities, and that's how B.Yond started. So let me remind, what the challenge is. So the challenge today is, on one side, the massive growth of data that is coming into the telco networks. The new applications which are performance sensitive. And from the financial aspect, you always have the challenge of either under-provision or over-provision your infrastructure. Over-provision means you're spending more money, which is not being capitalized or utilized, and the provisioning means you're impacting your customers. So that's the urgency of finding different ways of managing the networks and developing the networks. At B.Yond, we defined a vision of how the network should look in the future. You call it the 3Z telco, we call it the infinite network. And the infinite network is the network that is able to be available anytime, anywhere, able to launch services or workloads instantaneously where they're needed, and can scale to any size that is required to match the demand. So how do you get to the infinite network? We believe that it's through artificial intelligence and automation. So as a company, we are a software company, and we're leveraging AI and machine learning to drive automation. And we're looking at things like self-configuring of the network, self-optimization, and self-healing. Now, this is a nice concept, sounds like science fiction. So what we've done is we created actually a model, and we have a demo behind, and I'm going to talk a bit about that, of how you build that, and how do you take an example of a service that can leverage from that. So we created what we call the B.Yond intelligent network. We call it EDGI. And we're looking at a number of success factors for this network. So one is the network infrastructure. So we need to be aware of the network infrastructure and the topology in real time. So when you're building and developing your network, there's many activities happening. You don't know all the time 100% accurately what your assets are and what's running on them. So this is critical. That's one of the first elements. Second element is once you know all the infrastructure you have in real time, you need to predict the service usage and allocate the necessary resources. And then you need to be prepared for unexpected events. Now, how to develop that intelligent network? You need to break those problems into smaller problems. Use the right AI ML tools and develop them, train them to address those problems. But you're still touching those problems or solving them individually. Then the third step that we think is crucial is you need to enable those different algorithms to cooperate, to talk to each other, so that you actually achieve that second level of intelligence. So what is our demo? And you'll be able to see it in action, and you can actually interact with that demo. So what we created, and we're running this out of our cloud, is an emulation of a network which provides services at the edge. Now, we took a very simple example, which is streaming music, because we want you to be able to use your smartphone and be able to experience it. But it can be any other time-sensitive application, virtual reality, smart cities, automotive driving. So things that actually need to be deployed at the edge and need to be available when it's needed. So we created a number of nodes. You have here 2 nodes, Midtown, Downtown. And what we're going to do is we're going to deploy microservices, containers, Each one of them is going to be streaming one type of music, and that will depend on the usage. The typical approach, even though we are already showing here something that might be a next step evolution, which is an edge network, virtualized, container-based, fully automated, but you typically reach to a point where you start provisioning those services based on some predefined rules, which is if your traffic grows to a certain level, then you add more resources. What happens with those rules is you're either over-provisioning your infrastructure, that means that you're allocating more cost than needed, or under-provisioning your infrastructure. That means that your users are waiting. They're not being served. Now, for music streaming, OK, they might be willing to wait a few more seconds. But when you go to mission-critical applications, it doesn't work. So what's the way forward? When you use AI and machine learning prediction, then you can start adjusting the resources and deploying the resources exactly ahead of what you need. So that's what we call just-in-time allocation of resources. So that means that you're utilizing better your infrastructure, and you're providing exactly the service that the customers are expecting. No delay and good usage of your investment. Now, all sounds good. Have we solved the problem? Now, imagine that something completely unexpected occurs. You have a denial of service attack. Someone is connected to your network, and somehow they manage to consume some of your resources. In this case, is Midtown, and that's going to start impacting your customers that are being served from that resource. Usually, what it takes is you take this as a different action. You take potentially a security team that will investigate and will try to figure out and contain the attack. But while you're doing that, your resources are being consumed, and your music service is not playing well. Now, the algorithm to detect the denial of service attack can also be an AI/ML algorithm. But the algorithm knows that something is happening, is trying to take action, but your service prediction algorithm doesn't know. He's trying to allocate more resources, but the resources are being denied, and it doesn't know. This is where those algorithms can communicate. So the denial of service algorithm can announce that there's an impact, and that it requires some time to deal with that, and that the resource Midtown is being impacted. Then the services understands that it needs to find another set of resources to move the applications. And that's where the resource algorithm can declare which resources are available. So suddenly you have different automation elements cooperating with each other so that they continue to do what they need to do best and deal with the attack. So what we do in this case is start moving the voice services to downtown, where resources are available. Midtown is affected, but that allows the denial of service, the security algorithm, to continue working on identifying some forensics, probably, or containing that attack. And then we restore the normal usage of the network. So in this simple example, we're trying to show and demonstrate how applicable it is. Now, it still might feel like science fiction. So this is something that it's not that easy yet for you to deploy in your networks. However, you need to start somewhere. So we've already started as B.Yond. As I mentioned, we have a strong relationship with telcos in the US. We have access to a huge amount of data from their networks. And we've already started working with them, and we have already some commercial products out there where we're bringing automation in some of more, you could call it more basic areas, but where AI and ML actually brings a value. The first one is an interesting one. We call the network discovery and reconciliation. Believe it or not, 10 to 15% of your assets are stranded. What does that mean? And this is an industry measure, and we found that also with our customers. That means that you've either acquired assets that you have not deployed yet, because somehow they are, through the process of deploying them, they are delayed, or they are not accounted for from when you transfer that from one department to the other department. Or you do have assets that have been enabled in the network, but have not been reconciled to the inventory. so you're not able to bill on the usage of those assets. Now, by applying two things which are critical for AI ML type of tools. One is managing a huge amount of data and being able to model data even if they are not compatible, and applying AI and ML to find those relationships or broken relationships. You can, in real time, let's say, you can find those stranded assets and you can accelerate the deployment and usage of those assets. So there's huge value in terms of your spend, your CapEx. Smart CapEx planning is a predictive algorithm where we take the usage, and we've been applying this mainly to the radio networks. There's a lot of investment and changes, particularly in the US, that you need to understand better. So you need to provide a better planning where you're going to spend your money for the next 3 to 6 months, and making sure that you're making the investments in the areas where you're going to need the capacity. And then automated root cause analysis. Currently, we're applying this to lab testing, but you know for sure that testing new equipment requires many weeks and many months, and there's a complex set of testing that needs to be done. Now, there's a lot of automation that has been made on the test generation, but then looking at the results of the test and finding the root cause is still very much manual. And this is where we're bringing machine learning and AI, which is also a continuous learning system where your lab engineers can validate the results and much faster complete all the necessary testing and bring those new equipment to the network. So we see that 5G and automation drives new opportunities. And we believe that this is the right moment for you to start investing in this type of automation tools that allows you to automate your operations and make your network more intelligent, but also enables new revenue streams. I strongly encourage you to visit our demo there, and I'm happy to answer any questions you might have. Thank you very much.
So I would